Okay, now that we have the idea of polar form down, let's start to look at the first thing we'll do with it with calculus, and that is to find the derivative of a polar form equation. And the idea is we want to find maybe the slope of a tangent line of a polar curve, or maybe we'll want to find all of the horizontal tangent lines or all of the vertical tangent lines or something like that. So here we go. At the end of the day, the slope of a polar curve is taking the derivative of y with respect to theta and dividing it by the derivative of x with respect to theta. And what happens is you end up with all kinds of product properties and other things in. Really, probably the easiest thing to do is just memorize this formula. This formula takes kind of all of the ins and outs of how you would have to take the derivative of y divided by the derivative of x and all the different kind of nuances of those derivatives and just places it into this. And so if you can just memorize this formula, and it looks like a lot, but you'll see the top and the bottom are actually very similar to each other, then all you have to really do is whenever you want to find maybe the slope or whatever, you're going to find the equation of a line, but you need to find the slope, so the derivative, you'll be given a theta, and then you'll have to evaluate the function at that theta, the derivative of the function at that theta, and then cosine and sine both of that theta and plug them all in. So that's the gist of it. I'll show you one of these in just a second. I do want to point out that if we only want to find horizontal tangent lines, that could be an instruction, then you just need to work on the top part, dy d theta. If it asks you to find vertical tangent lines, then you only need to work on the bottom part, dx d theta. But there is one kind of really important thing that you could encounter, and that is if you ever get the same theta answers for both, so maybe you're trying to find the theta that creates horizontal tangent lines and vertical tangent lines. Well, if you ever get a theta that works like maybe here theta is pi thirds and pi, and maybe here theta is pi thirds and 2 pi thirds. Well, if you ever get the same one, then that actually is not an answer. We just cannot say exactly what's happening there. We do not include those thetas. So if you're ever asked to find horizontal or vertical tangent lines, you actually have to find both. Even if you're only asked for one or the other, because you cannot have an answer that is in both. You disregard that answer. Okay, so let's actually practice one of these derivatives. So let's imagine that I have a function, and that's it's 1 plus 2 cosine of theta. It's a limousin, and I want to find we want to find the slope, maybe to the tangent. And we'll say at theta equals pi sixth. Okay, so I actually have a graph here. This is that limousin, and you can kind of see in the top right of the screen where pi sixth is. So we're looking for on the top right of that polar graph, that polar curve, we want to find the slope of that line. So I can see that it's negative. And yeah, we'll figure it out. So here we go. Again, the best thing that you can do is memorize that formula at the top of the screen. It's just going to make your life easier. And so what we can actually do is we can do a little prep work first. So we can start by saying, okay, well, what's the function evaluated at pi sixths? So we'll plug pi over 6 in for theta. And cosine of pi 6 is square root of 3 over 2. So this is 1 plus 2 square root of 3 over 2, which is 1 plus square root of 3. And then we can just go ahead and do that, the derivative then. So the derivative of theta, first of all, would be negative 2 sine theta. So then we can find the derivative of pi over 6, negative 2 sine pi over 6, which is negative 2 over 1/2, which is negative 1. So we're just getting some prep work out of the way, stuff we're going to plug into that formula you need to memorize. Let's see. So here is the derivative at pi 6. Here's the function at pi 6. A little bit more prep work. Let's just make a note over here at the bottom that sine of pi 6, we're going to use that quite a bit. I just used it, is 1/2. And cosine of pi over 6 is square root of 3 over 2. Okay, so taking those highlighted yellow pieces of information, we're going to plug it into the formula up above. I'm going to zoom out a little bit and try to get all this on one screen. So here we go. So the derivative, the slope of this tangent line evaluated at pi over 6 will be the function of theta. So that would be 1 plus square root of 3 times the cosine, okay, I'm up here on the formula, times the cosine of theta, which we said is square root of 3 over 2. And then plus, now it's the derivative evaluated at pi over 6, which is -1. So -1 times the sine of theta, which is 1/2. Now on the bottom, we're just going to go through the bottom. There is a negative sign there, so we want to be careful for that. So we want the negative function of theta. So I'm going to say the -1 plus square root of 3 times the sine of theta. Sine of theta is 1/2. Plus the derivative evaluated at theta, which is -1. Times, finally, the cosine of theta, which is square root of 3 over 2. Okay, now that's a mess. And, of course, for a response question, we'd be done. But there's a lot of cleaning up to do here. And what you find is a lot of things cancel out and kind of reduce pretty nicely. So let's work on top here. We'll distribute property first. Square root of 3 times 1. Square root of 3 over 2 times 1. Square root of 3 times square root of 3 is 3. Whoops. Let's fix that. So plus 3 over 2. And then minus 1/2. So there's the top cleaned up a little bit better. On the bottom, we'll distribute the half and the negative. So -1/2 times 1 and negative square root of 3 over 2. And then we have a negative square root of 3 over 2 at the end there as well. All right, so let's see what we have. We have square root of 3 over 2 plus 1. And down here we have -1/2. We have 2 square roots of 3 over 2, so those 2's cancel out. Let's keep going. So we could get a common denominator on top, and we could get a common denominator on bottom. And now we can, dividing, we can multiply by the reciprocal. So kind of get rid of that. And we can bring that negative out. Square root of 3 plus 2 over 1 plus 2 square root of 3. So some version of that is the actual correct answer. So what did we find? We found the slope, okay? The slope using that formula at the top of the screen. But we found the slope of the tangent line for our function at theta equals pi over 6. And if we go back to this graph that I made, there's our original function. And if you put that answer we got into a calculator, you get a slope of about -0.8366. So I can graph this on here as well and show you that you can see there at that intersection at pi 6, we have our tangent line, and that's the correct answer. So that's really the gist of everything you need to know for this part of the lesson. Just remember then, the only other thing you really might do is find horizontal tangent lines or vertical tangent lines. You solve for theta by setting your top equal to 0 for horizontal and your bottom equal to 0 for vertical. All right, thank you very much. Have a good day.